Today is the 6th of 26. For you guys who had Algebra 1 last year, you will have seen this before. I apologize for the inconsistencies. The vast majority of you are 11th graders to whom I taught Algebra 1 2 years ago. And I believe in that year, this was one of the years I go kind of back and forth sometimes. I do take some liberties with what I do and don't teach. And sometimes it's based on the clientele. Sometimes it's just based on how much time I have. Um, but for whatever reason, for you guys who had me 2 years ago, you've never done this before. For you guys, you ninth graders who had me last year, you have, I think, from what I hear, done this before. So apologies in advance for you guys that might feel a little like, hey, I know this, but we gotta get her done. So this is the second of the four ways to solve quadratics we're going to talk about. Okay, it's completing the square. And before I know this much, before I start the lesson, we have to do two little mini lessons. So the two things we have to talk about before we get going are, first off, are you good at this? Uh, you know the red list. You know, we've talked about the red list, especially in ninth grade, Algebra 1 ad nauseum, right? The red list consists of numbers that are square rootable. So like if I asked you for the square root of 9, you'd say 3. The square root of 144, 12. Like you know these ones, but what's the square root of 40? What do we do? Yeah, Cody, we do. And we draw little branches, and at the bottom of each branch, we put a little blank square root sign. Some people don't put the blank square root signs, and it's can go both ways. Some people get away with it, and I don't yell at them, and then some people really make the exact mistake that I'm trying to get them to avoid. So my advice is draw the blank roots before you learn what goes in there. So there are lots of numbers that multiply to make 40. What's the only pair that's good? 4 and 10, right? We don't want 8 and 5 because 8 and 5 are not on the red list. We don't want 2 and 20. We want specifically to use 4 because it's rootable and 10. So the answer to the square root of 40 is 2 root 10, we say. And why don't we break down root 10?
Because it's not.
It's garbage, right? If I did break it, I'd break it into 2 and 5, but it's pointless because neither of those are any good, right? So let's practice a few more roots. I jotted a couple down. How about the square root of 192? If I taught you algebra a couple years ago, I probably had you on a wild goose chase going through the red list and trying to, bless you, trying to divide by things that are good, like 4 and 9 and 16 and stuff like that. I really last year, maybe earlier this year, I don't really remember. I kind of went pretty heavy full send into a different method for this. Has anyone found 192, bless you, while I was yapping? A lot of times the mistake we make is we stare at the red list and we look for numbers, and it'll take you a long time to find it if you go that route. Another really cool strategy is to divide by little numbers that don't mean anything. So I didn't mean for this to be a big lesson on roots, but we have to go down this road. So just don't write this down. But I know you got it, Oliver. Just give me a sec here, buddy. If I divide by 2, like 2 is a useless pile of garbage, right? 2's nothing. And I get the other number is 96. And 96, we agree, is also nothing. So 2 was not the right. I call those baby trash numbers. They're little numbers that are completely worthless, but they provide for us on the other end the numbers that we look for. Oliver, what did you come up with?
I had over 12, but you can split 12.
Nope. So let's keep down this. I really want to go down the same road. I really want you listening to what I'm saying right now. Listen to what I'm saying. This will help you when the roots get bigger. 9 times out of 10, that's a great strategy. Divide by numbers that you think don't mean anything, like 3. 3 is trash. Whether you use a calculator or not, what is 192 divided by 3? I love that. It comes out to 64. So what I did is I found a red listable number by not really looking for it as much as just taking like a really indirect sort of backdoor approach there. So using 3, expose the 64. What overall then is the answer to 192? 8 root 3. Good job. Okay. You want to be really good at this because, we're not spending a day on this like we would have before. We want to brush up. You don't want to be slowing down every time a radical or a root comes your way. How about this one? Nice and simple. What goes in there? 9 and 7 are what I'm looking for. Thank you for actually answering the question. So 9 goes here and 7 goes here, right? Because 9 times 7 makes 63, and nine's awesome because it's on the red list. And I know it's the best one because 7 can't go any further. So the answer to root 63 overall is 3 root 7. You guys okay on that? Is that a good refresher for you? I will say that this, if you are not good at this, you should let me know. And I'll help you with that in a couple ways. Number one, I can kind of sit and coach you. But number two, these are really easy to generate by the hundreds. So like if you said like, could I get some? I could give you like 50, 20, 100 of them just to sit and drill and practice. I'd love to help you with that. But that's a really critical skill for everything now that we start doing. Right. The second side topic of the day is today's notes are called completing the square. And the question to be answered here is, what's a square? And in geometry, Mr. Manlove would have taught you that a square is a four-sided polygon with four right angles and four congruent sides, right? But in math, in non-geometric math, we talk about square in a different way. Like, why is 25 a square? Because it is something squared, correct? Yeah. So because 5 squared results in 25, we call 25 a square, right? So how about this? Would you believe me if I told you that this is a square? Yeah. It's not because x is squared. Okay. Yes. I'll tell you this, like this is not a square. Because when I factor the one on the right down, it factors into x minus 8 times x plus 4. That's not interesting at all. But good job, Cody. When I factor the one in the middle, it factors into x plus 5 times x plus 5, which is x plus 5, well, squared, proving that that is a square. So again, anything that I can say was obtained by squaring something else, I can refer to as a square. Okay, so let me do another square, and then you're going to start helping me write the squares. So here's another example of a square. Prove to me that it's a square. Help me with your, together, let's prove that it's a square. Ollie?
Well, so first you're going to want to factor it. So it's going to be both addition because the second symbol is addition.
No, if the second symbol is addition, it means they're both the same.
And then the first symbol means that they're negative.
And what numbers multiply to make 36 that I'm interested in?
Well, you want the numbers to add together 12, so
6 and 6. So again, I'm trying to work with you to show you that if I factor something down and it comes out to something times itself, then it by definition is a square. That one was a little bit bumpy. Let's do one more. I'll just kind of freestyle a new one here, and we'll talk through why it's a square. Okay, so let's do like k squared plus 18k plus 81. Let's leave this example here in 30 seconds, all of us understanding what it means to be a square. Why is this a square? Yeah, Hayden? Yes, and 9 plus 9 is also, yeah, good. So when I factor this down, it factors into k plus 9 times k plus 9, aka k plus 9 squared. We clear on that idea? Yeah. So then to finally transition us into the lesson now, we need to talk about what does it mean to do what the notes say at the beginning? What does it mean? What is this completing the square? Well, if I start and I put something like this, blank. Your job now is to play the role of the math teacher and say, okay, if I'm writing a math problem for my students and I want this to be a square, There's a number that has to go in the blank. It's plus 49, right? And that's just algorithmic. It's procedural. You understand that if I put a 49 here, this will factor down into W minus 7 times W minus 7, right? And some of you are already onto it. Like you don't have to reason your way through this. Like just knowing what number to put there, it happens quick. Let's do like R squared minus 20R blank. Go. I heard someone mumble it. Still hearing whispering, but I'm going to write it down anyways. Plus 100 is beautiful. So the question for the rest of us is, well, how are we doing this? Where is this number coming from? Like I don't see where these are coming from. There's a process. It's the same every time. You can repeat it. It's reliable, and it goes like this. What's half of negative 14? It's negative 7. Square negative 7, what do you get? That's how you complete a square. That's the missing piece is I take half of the middle and I square it. And I can do it again and again and again. What's half of negative 20? And what's negative 10 when you square it? 100. The act of putting that number in that place is called completing the square. It's it sort of defines itself. Bless you. By putting a number in there, I am completing something that I want to be a square, right? How about this one? Ready, go. Make it a square. I mean, there's a lot of things I could put there that would make it factorable. I want it to be a square, Lex. Yeah. And by the way, will this number that I'm putting in the blank always have a plus with it? Oh, yeah, because it's something squared, right? So that is how you complete a square. So let's do one more because this is going to be a little foreshadowing. This guy's going to pop up later in the lesson. How about n squared plus 2n blank? Follow the algorithm. It will not lead you astray. It is 1 because half of the number in the middle is plus 1. 1 squared is 1. So I rely on faith. You could prove it. You could show that it's a square. Factor it down. It'll be n plus 1 times n plus 1. So finally, the last bit of transition for this lesson is, well, what does this mean for us? Well, this is how you use completing the square to solve equations. So I present to you official example 1 after all of that. And if someone thinks of it later, you can remind me this is not the best method to solve quadratic equations all the time. It's my favorite when it works. I love the process of it, but there are problems where it's so tricky with fractions and stuff where it's almost like, no, I'll pick a different method. If I'm any good at this, if we're any good as a team, by this time, maybe middle end of next week, you guys will confidently be able to say, I can look at a quadratic and know if I should use square roots, completing the square, factoring, or the quadratic formula. But the completing the square, I love under certain circumstances. So here come the steps. Are you ready? Step 1 is get it to look like this. I took the minus 12 and I said skedaddle and I left an empty space. You don't have to do this. There are ways to not move that 12, but I know from back and forth over the years that just clearing it the heck out just makes this a lot simpler. So I'm moving them out. And what I'm going to do is in this little landing pad right here, I am going to complete the square. What magic number is going to go there? 25. So plus 25. But as you know from years of doing math, if you do it on the left, you do it on the right. Still might be going, I don't see why I would do this. Well, let me show you. What we're going to do now is we're going to factor the left-hand side down. And we're not going to factor it like some rookie into x minus 5 times x minus 5. We're going to factor it into x minus 5 squared. That's so sweet because I can package all my xness into one spot. Bless you. I can package it into one spot and I'll show you what to do with it here in a sec. You do have to do the math on the right. 12 plus 25 is 37. I considered this being a third little side lesson, pre-lesson, but I skipped it because we can just talk about it right now. At this point, does anyone have any big brain ideas on how I can get that X out of there? He's trapped. He's in math prison, and that's not okay. Because if I'm going to get X by itself, I need to get rid of some stuff and clear a pathway here. Any thoughts on that?
Reach both sides.
Root both sides. If I take the square root of this side, the green square root sign will cancel the green exponent, right? You know that in math, everything can be canceled. Pluses cancel minuses, times kills divide, squares kill square roots, whatever. So if I do it on the left, I do it on the right. And when the square root and the exponent collide, I am left with x minus 5. And at that point, the captain has turned off the seatbelt sign. X and 5 are both free to move about the cabin now. It's at this point, make a note of this, and I'm going to stop, slow down, maybe pour some coffee so I make sure you make a note of this. It's at this exact point in time in this process that you have to put a positive negative sign. And I'll show you why. A little bit of a side note, I'm going to switch colors. If I said to you x squared equals 36, what's the solution to that equation? X equals 6 is the most common wrong answer. And it's not wrong. I shouldn't have said it that way. It's not wrong in the sense that you're not right. Like 6 squared obviously equals 36, but it's incomplete, right? Isn't there another number, Nash, that if I square it equals 36?
It's equal.
Correct. Positive, negative 6, I think you meant. Correct. Understand that in the context of solving an equation, I have to consider that, yes, if Hayden squares 6, yeah, he gets 36, but then Nikki could turn around and square negative 6 and also get 36. So in the context of where we're at in that problem, saying positive negative is required because there's two roads you can take, right? And then the final step, and we're done, is to add 5 to both sides. And we're going to say x equals 5 plus or minus the square root of 37. Done. How many answers are in this box? Read one of them to me. One of them is 5 plus the square root of 37. What's the other one? Correct. So just like we do with the quadratic formula, they're packaged up. It's a two answers kind of in one spot. What's the square root of 37? Ballpark it.
6.
6 and change, right? So one of the answers is like 5 plus 6 and change, so like 11 and a little bit. And then the other one's 5 minus 6 and change, so like -1 and a little bit. All right, next example will not take as long. That one is always the slow one. So here we go. We should be able to cook through the rest of these. There are some new ideas that pop up along the way, and we'll just talk about those kind of as we go. All right, let's hit it. Step 1. What did you say? Get that 80 the heck out of there, right? So we know structurally how we want this to look. We want n squared, sit, stay, 16n, sit, stay, 80, get. Make like a banana and split. Get out of here. So the other side is now going to be 3 plus 80, also known as 83. And there it is. That's the structure you want right there. That's how you want every completing the square problem to look. Oh, just like that. That landing pad is open. And what's going in there? 64 is correct. Half of plus 16 is plus 8. 8 squared is 64. So we're going to add 64 here, and we're going to add 64 here. Let's factor the left-hand side down. What does this become? Correct. Good. Right side, math, 147. And we made it to the place where we square root both sides. If I square root the left-hand side, I just get n and 8 free to move about the cabin. And what am I going to put before I forget? Positive negative sign. Do it right away so you don't forget. It happens there. It doesn't happen before there. It doesn't happen after there. That's the moment when he shows up. And then I'm going to put the square root of 147. And I'm going to head off to the side, and you guys are going to help me break this down. And I see a hand popping up, which tells me you might have already found it. Yes.
7.
So what numbers will I put in my square roots? If I divide by a little baby trash number like 3, I get 49. Nice. Which then leads me to 7 root 3. So with everything you see on the board right now, what is the final answer of this problem going to be? N equals what? -8 plus or minus 7 root 3. Nice. Questions there? That took about a fifth as long as the first one. This next one, watch out. Something happens and it's... Uh-oh, did I go too fast? Is that enough? You good? You sure? Okay. All right. It's a third example. Maybe not the right time to put this in there. Maybe third is where we lock in and say, I get this. But third one comes and your dumb math teacher puts in something that you don't know yet is a little bit special. Let's start with the structure. Let's build it, make it look the way we want it to look. Who's moving where? Yeah, basically these two idiots just have to change places, right? So x squared says I'll stay. 10x hoofs it over and becomes plus 10x. We leave that awkward space, and then 56 hoofs it over to the east and becomes a positive 56. Structure, perfect. There it is. And then you just follow the steps. They never change. What's half of 10? 5. What's 5 squared?
25.
25 is our dude. So we're going to add 25 right here, and we're going to add 25 right here. Does anyone see the uniqueness of the situation already? Left side factors into what?
It's close.
56 plus 25. If you don't see it yet, come to recognize it. What are we about to do? We're about to square root both sides. And I'm going to just put x plus 5 equals, I'm going to put positive, negative. I don't want to be that kid that forgets. And what's the square root of 81? 9. This, I've been using this word more and more each year as a pathway problem, and I'll show you what I mean by that. If I follow the normal procedure here, I'm going to move the 5 over, and I'm going to tuck it right where that arrow's pointing, right there. And my answer, which I do solemnly swear to not leave like this, is -5 plus or minus 9. This word in mathematics has vexed young people, learners for decades. What does it mean, and why does everyone put it in their problems? What does it mean to simplify? It's not the stupid question you think it is. What does it mean? Yes, it means to math until you can't math. If you look back at the last problem, like -7 plus or minus 2 root 7 or something, like I can't do anything with that. But I can do something with this. I can trace a pathway. I'll circle one of the pathways for you. Plus. Follow that pathway. What's -5 plus 9? Correct. So one of your answers is 4. The other pathway is minus. What's -5 minus 9? Your other answer is -14. And just to make this a full package deal, what does that mean? It means you could have factored. It means the original problem, had I written in standard form, x squared plus 10x minus 56, if this were on yesterday's assignment, I could have just factored it down into x plus 14 times x minus 4. And there's my answers, -14, 4. So anytime you get answers that come out nice, it just means that you could have factored. It's a hindsight thing. Next one, round 4. It's all about that structure, building the base correctly. Who has to move? I want it to look the right way, or I'm just shooting myself in the foot. Move the 12y, leave the 80. So we're going to have y squared. What's after that?
Minus 12y.
Minus 12y. Awkward void equals 80. That awkward void is always your landing strip for the red number. It's 36. Add it to both sides. Left side, what does it factor into? Minus 6. And then the right is just some basic kitty math. What's 80 plus 36? 116. What are we ready to do now? Root that sucker. So we have y minus 6 equals positive, negative. And I'm going to head over here to the side, and you're going to help me. Let's work as a team. How do you break down the square root of 116? 4 and 29. So it becomes 2 roots of 29. One step to go. Take that 6, move it, and tuck it right there. What is our answer going to be?
I equals 6 plus or minus 2 squared. 2 squared. Yeah.
Perfect. 2 more. How fast can we get them done? I don't know. How you feeling? You feeling like you're on board? This is a great method for solving quadratics. In fact, I'll show you that it's okay. Like, I am okay if you just go right from there to there. Right? And some of you might not be comfortable with that, but I mean, I would totally understand if you start multitasking and like simplifying a root and moving the other guy, just do it all at once. Big time saver. You can get completing the square down to where you can solve a non-factorable quadratic in like 11 seconds. It's pretty rad. Next one. K squared minus 6k minus 23 equals negative 4. I don't remember why this problem's in the lecture. Let's find out. I wonder what it has in store for us. What do we move? It's not ready. Move that dumb 23 out of there. So we got k squared minus 6k awkward void equals what? I think someone just whispered 19. I can't hear anything because of the air blowing through the vents, but if I hear a noise that sounds like the right number, I'm just going to go with it. So 19 is gorgeous. Now we're going to algorithm procedure this sucker. What's half of negative 6? Negative 3. Negative 3 squared is 9. So we're going to add a 9 in that void and add a 9 in this spot over here. I wouldn't recommend that you skip the next step. I'm not going to say that you can't. I'm not issuing a challenge, but I think this next step is pretty important to show. So factor. And then from here, come on, you mental giants. If I skip the next step, can I go right to the answer? Help me. K equals what? I heard something good. I heard a 2 root 7. That's definitely going to be a part of this. Keep it coming. Give me more. It's 3 plus or minus 2 roots of 7. You can do all that kind of upstairs, right? Simplify the root, move the 3 over, get it all done. Save a step. Love it. Last one. R squared minus 3 minus 2r. This is it. We made it to the end of the note card. In fact, I can get rid of this. There it was. Goodbye. What do we do? Yeah, I tried to trick you. This problem, I had 2 motives. Number one is just to try to put things in a strange order, but you guys are strong. You're such an amazing class. So we're going to leave the r squared. We're going to leave the minus 2r. We're going to leave a void and move the 3. Boom, there it is. What's the magic number that we add to both sides? It is 1. Wanted to make sure you got to see this one again. Half of negative 2 is negative 1. Negative 1 squared is plus 1. Add 1, add 1. What do you see coming? 4 is rootable, which means it's going to be a pathway problem, which means I'm going to have the x equals comma x equals scenario here. This isn't going to stay as a plus or minus or rooty tooty thing. So here we go. Left side factors into r minus 1 squared. Right side is 4. Well, I don't want to make anybody mad, but I feel like I could jump right now to r equals 1 plus or minus 2. Any issues with that?
Nothing.
Oh, no, it's a pathway problem for sure. We're not done. Let's take the top road. What's 1 plus 2? Yes. And then let's take the bottom road. What's 1 minus 2? It is not 1. It is negative 1. There you go. And all that means, again, is that going back to the very beginning, the original problem, r squared minus 2r minus 3, just simply could have been factored. Done. And there's your answers. Right? All right. You are now the proud owner of 2 things. And honestly, some of you already learned both of these. So this unit doesn't take long. Quadratic formula will be next. Square roots will be after that. But now you know factoring and completing the square. And then I'm going to hand out the worksheet. You're going to work super hard for like 9 minutes. And then tomorrow I'll just give you a nice me out of your way work day to get some stuff done. Please use your time wisely. The next 9 minutes are not free time for you to catch up on your socializing.